Alright, so we'll start from the very basic, the definition of remote sensing. I think this image right here is pretty much self-explanatory already. So, remote sensing is indeed a process of obtaining or acquiring data of information of objects without making physical contact with it. I repeat, remote sensing is a process of obtaining information about objects or areas on Earth from distance without making any contact with the target or the object. And it's usually done from aircrafts or satellites. The process itself involves an interaction between incident radiation and the targets of interest. It also involves the sensing of emitted energy and the use of non-imaging sensors. Alright, now let's start getting into a more detailed explanation of remote sensing. So, as I explained before, the process of remote sensing itself involves some interaction that now I will try to break it one by one so we can all understand a little more about how remote sensing works. So, there's an image right here. I will try to explain. The first one is A, energy source or illumination. So we need energy source to illuminate and provides electromagnetic energy to the target of interest, to the objects. And the second one is B, radiation and atmosphere. So as the energy travels from its source to the target, it will come in contact and interact with the atmosphere. This is an unavoidable process. Okay, let's move on to the next process. Is interaction with the target, the C. Interaction, so once the energy makes its way to the target through the atmosphere, it interacts with the target. But it depends on the properties of both the target and the radiation itself. Okay, the next one is recording of energy by the sensor. So after the energy has been scattered or emitted from the target, we require a sensor. We require a sensor to collect and record the electromagnetic radiation. The fifth one, the next one, is transmission, reception, and processing. So that when the energy is recorded by the sensor, it has to be transmitted to a receiving and processing station, where the data later will be processed into an image. It's either in the form of hard copy or digital or both. So the next process is interpretation and analysis. The process image will be interpreted visually, digitally, or electronically in order to extract information about the target which was illuminated by the energy source, like I explained before. And last but not least is application, the final interaction, the final element of the remote sensing process. So it happens when we apply the information we've been able to extract from the imagery about the target in order to better understand it, or reveal some new information, or assist in solving a particular problem.
What is a SST?
After we know what remote sensing is, we should know what is remote sensing used for. Remote sensing can be used for the first one is large forest fires can be met from space, allowing rangers to see a much larger area than from the ground. The second is tracking clouds to help predict the weather or watching erupting volcanoes and help watching for dust storms. Tracking the growth of a city and changes in farmland or forests over several years or decades. And the third is discovery and mapping of the roots topography of the ocean floor. Example, huge mountain ranges, deep canyons, and the magnetic stripping of the ocean's floor.
Sea surface temperature is the water temperature close to the ocean surface. It varies mainly with altitude, with the warmest waters generally near the equator and the coldest waters in the Arctic and the Antarctic regions. As in the oceans absorb more heat, sea surface temperature increases, and the ocean circulation patterns that transport warm and cold water around the globe change. SST was one of the first oceanographic variables measured, yet it is still a fairly new phenomenon. The first recording was in the late 18th century by Benjamin Franklin, who suspended a mercury thermometer from a ship while traveling between the US and Europe. SST was later measured by dipping a thermometer into a bucket of water that was manually drawn from the sea surfaces. Today, SST measurements is obtained by satellite microwave radiometers, infrared radiometers or IR, in situ moored and drifting buoys, and ships of opportunity. Different instruments measure the temperature at different depths. For instance, most buoys have sensors located at about 1 meter depth of placed at regular intervals along a tether line. When measured from space, sea surface temperature represents a depth that is related to the frequency of the satellite instrument. For the example, IR instruments measure a depth of about 20 micrometers, while microwave radiometers only measure a few millimeters. Satellite infrared data is merged with the temperature data drawn from ships and buoys to create a holistic understanding of the sea surface temperature at a larger scale. We've come a long way from the bucket method. Why does SST data matter? While heat energy is stored and mixed through the depth of the ocean, the temperature of the water right at the sea surface, where the ocean is in direct contact with the atmosphere, plays a significant role in the weather and the short-term climate. The ability to measure it allows us to observe the global system and quantify ongoing weather and climate change.
What is an infrared? Infrared is electromagnetic radiation with wavelength lower than those of visible light. Infrared is generally understood to encompass wavelength from around 1 millimeter to the nominal redhairs of the visible spectrum, around 700 nanometers. Longer infrared wavelengths are sometimes included as a part of terahertz radiation range. As a form of electromagnetic radiation, infrared propagates energy and momentum with properties corresponding to both those of a wave and of a particle or the photon. Infrared and remote sensing use for sensors to detect infrared radiation emitted from the Earth's surface. The middle wave infrared and long wave infrared are within the thermal infrared region. These radiation are emitted for warm objects such on the Earth's surface.
Is SST all around the world different? Sea surface temperature is the most important water quality parameter in the oceans, especially coastal areas. Sea surface temperature is one of the main factors in the movement of the seasonal cycle in both tropical and subtropical areas. Where sea surface temperature affects atmospheric conditions, weather, upwelling, and seasonality, even the emergence of El Nino and La Nino phenomena can be studied through sea surface temperature. Meteorologists have long observed sea level, especially sea surface temperature, as the main candidate for causing low-frequency atmospheric change. Understanding the relationship between the ocean and the atmosphere is not only important in understanding in climate system, but also has wider practical implications, namely in weather and climate prediction. From simulation of interdecadal climate system variability showing a close relationship between the ocean and the atmosphere. Sea surface temperature is different because it is influenced by several factors. 1. Angle of incidence of sunlight. It can be seen in the daily apparent movement of the sun and the difference in latitude position. The apparent daily motion of the sun starts from sunrise to sunset, forming the angle between the position of the sun's movement with respect to the Earth's surface. 2. The intensity of sunlight. The amount of sunlight received by a place will affect the temperature at the place, such as the equatorial region, where the intensity of solar radiation is the highest compared to other areas. 3. Altitude of place. At the Earth's surface, the law of temperature gradient applies. That is, every time the altitude rises 100 meters above sea levels, the temperature will decrease by 0.6 degrees Celsius. 4. Atmospheric condition. Depending on the weather that is happening at the time, it is cloudy or raining. Of course, the air temperature will drop.
How we can get a SST data? SST data can be obtained from NASA Ocean Color by following the steps below. Number 1. Please open the NASA Ocean Color website and click on the top. Number 2. Click Service and User Registration to create an account on Earth Data. Number 3. Select the Create an Earth Data Login Account section to fill in the user profile data. Number 4. Write the username and password that will be used for the Earth Data account. Number 5. Click the Data section and browser Level 3 to get data sea surface temperature. Number 6. Make setting on the satellite and sensor section. Some of the choices are Modis Aqua, Modis Terra, and Fierce SNPP. After all the options on the product status match the data to be downloaded, the display will look like the one below. And then we can click on the available World SST image session. Number 8. After selecting one, it will look like this. Then, to download the data, we have to click 1WBIN section. Next, it doesn't take long. Your browser will download immediately, and you can use the data you want.
Now I want to tell about layer of the ocean. Sea surface temperature or SST is the measure of the energy created by the motion of molecules at the top layer of the ocean. When dealing with surface temperature data, it is imperative to know very accurately to which depth in the ocean measurement corresponds to. The following is a layer of sea surface temperature measurement. Number 1. Interface temperature or SST in. This corresponds to the external air-sea interface layer. Yet actually this is of no practical use since the temperature at this level cannot be measured using current technology. Number 2. Skin sea surface temperature or SST skin. This is the temperature measured by an infrared radiometer within the 3.7 until 12 micrometer wavelength range. It corresponds to a layer of 10 until 20 micrometer depth. SST skin measurements are subject to a large potential lunar cycle. Number 3. Subskin sea surface temperature or SST subskin corresponds to about 1 millimeter depth. For practical purpose, SST subskin can be well approximated to the measurement of surface temperature by a microwave radiometer. Number 4. Surface temperature at depth or SST depth. All measurements of water temperature beneath the SST subskin are referred to as depth temperature or SST depth. Such temperature may be obtained using a wide variety of platforms and sensors such as drifting buoys, vertical profiling floats, or deep thermistor chains. Number 5. Foundation temperature or SST-FND. For the depth where SST-FND corresponds to there is no influence of the diurnal temperature variability. The SST-FND or foundation temperature can only be measured using in situ contact thermometer.
MODIS, Moderate Resolution Imaging Spectral Radiometer, is an important instrument aboard the Terra, EOS-EM, and Aqua EOS-PM satellites. This satellite was launched on December 18, 1999. Terra and May 4, 2002 Aqua is a NASA mission that can observe phenomena on land, sea, and atmosphere. The Aqua Terra MODIS satellites observe the entire Earth's surface every 1 to 2 days, obtaining the data in 36 spectral band and channels or groups of wavelengths. The Aqua Terra MODIS satellites imaging is for SST monitoring and study because it has a high thermal band and temporal resolution, so that the dynamics of SST change can be observed continuously. The MODIS sensor on the Aqua and Terra satellite has 36 spectral bands consisting of 1 to 19 visible band, 26 infrared band, and the rest are thermal bands. The Aqua MODIS satellite circling the Earth every 1 to 2 days with an orbital trajectory from the South Pole to the North Pole, ascending north at an altitude of 705 kilometers and sweep width of 2,330 kilometers. The satellite has a sun-synchronous polar orbit, crossing the equator at noon approaching 1:30 p.m. local time. The satellite image has three spatial resolutions, namely 250 meters band 1, band 2, 500 meters band 3, band 7, and 100 meters band 8 until band 36. The SST obtained can be informal of level 1B and level 2. It needs to be corrected first. In addition, SST from the Aquamodis model satellite is also a composite level 3 with a spatial resolution of 4 kilometers times 4 kilometers. This Aquamodis level 3 satellite imaging has been radiometrically and geometrically corrected.